Hey everyone, it's Bobby from Dig Coding here, and this is another video from my Hedera Hashgraph Python playlist that I'm putting together for you. If you've been following along, you'll know now that I'm putting this tutorial together to help you as a Python developer to start working on Hedera Hashgraph, because there is no native Python SDK currently. However, there is a wrapper that allows us to work with the Java SDK, and that's what I've been working with. I've put together 6 videos so far. We've gone through the documentation on Hedera and gone through all of their getting started links, and in this video we're going to move away from that getting started stage and start doing a bit of a deeper dive on their SDK, or SDKs should I say. But before we do that, before we jump into it, if this is the first time you visited Dig Coding, then please click the subscribe button and click the bell so you are notified every time I add a new video to this channel. And also, if you want to support us, then there's a link to our Patreon page and our HBAR wallet in the description below. So let's jump straight into it. Look on my screen. It opens up straight on my YouTube playlist for Hedera Hashgraph and Python development. You can see there's 6 videos, right? So I've gone through, like I say, the documentation on Hedera and gone through all of their getting started bits and pieces, and these videos give you a step-by-step guide of what to do. So we're setting up the machine, installing the wrapper, configuring the Hedera network. This is where we start getting into the getting started stages on Hedera. Then we're creating accounts. We're transferring HBAR. So if you don't know, HBAR is Hedera Hashgraph's native cryptocurrency. And then we're working with the Hedera Consensus Service. So we're using the HCS to send messages, like I say, on their consensus service. So that is the end of their getting started tutorials. So like I say, we'll be moving above and beyond that now. Everything in this playlist is loosely based on the wrapper SDK that can be found here. So it's the pypi.org. So somebody's put this Hedera SDK PY together, and I've been using this because this has really been the foundation of me being able to work with the Java SDK. And if you look on here, they've got a link to examples. Takes you through to GitHub, and there's a whole bunch of code in here that you can use as a very valuable resource. There's also a link to my GitHub repository in the description below, and that will be to the app that I'm building in this tutorial. So the Hedera Token Service. So if you don't know what it is, their HTS is a service that allows us to configure, mint, and manage native fungible and non-fungible tokens, so NFTs, on the Hedera network without the need to deploy a smart contract. Okay, so it's a great service. Their 2 main services are actually HTS and HCS. So this is one of their core services that we're going to be working with today. If we go into their documentation pages, so if you're going to SDK, so docs.hedera.com/guides/docs/SDKs, you'll be familiar with this if you've been watching along with these videos, because we've been working along with these getting started links for Java. Again, we've got the environment set up, create an account, transfer HBAR, and submitting messages. So this is what we've already done in previous videos. So if you scroll down to the bottom here, we've then got, where are we? Yeah, we've got the SDKs here. So the documentation, we've got release notes and SDKs. So a whole bunch of stuff in here, lots of resources. It's great for bedtime reading, but we're not going to go through them in a great detail right now. We're just going to look at the token service. So we pull that down. You can see here, we've got a whole bunch of resources in here, but if we click on token service, it'll take us to the main page, SDK/tokens. And you've got token IDs, create a token, and so on and so forth. There's loads and loads of bits and pieces that you can do to just read through these docs. But if you start with token ID, there we have it. And actually, no, we'll start with create a token. So create a new token on a Hedera network. After you submit the transaction to the Hedera network, you can obtain the new token ID by requesting the receipt. Smart contracts cannot access or transfer HTS tokens at this time. Okay, so have a good read of all of these bullet points because it goes through in some detail. One thing you might want to look at as well is the supply. You need to set an initial supply for the token because that will be applied to the operator or the treasury account, which is going to be us, and you need to set an initial supply. So where we got here, so the token A, this is an example, token A has an initial supply of 10,000 and decimals are set to 2. Therefore, the tokens that will be put into circulation are going to be 100. See how that works? So it's 10,000, decimals of 2, so the tokens will be 100. Okay, and it goes through, it gives you another example there. So get your head around that, how that works, and that will allow you to then create the tokens. But I've already coded this up anyway, so we'll be walking through the code and walking through it and actually testing it towards the end of this video. So there's the method we'll be using is token create transaction, and then we've got different methods for this constructor, should I say. And so we've got set token name, we'll be calling that set token symbol, decimals, and there's a whole bunch of methods here. And then it's got some example code here. Okay, so this is what my code has been loosely based on, which we'll start writing in a moment or two. We've then got, we will be looking at, there we go, we've got to transfer tokens from one account to another. You need to associate a new account to the token itself. So first and foremost, what we do is we create the tokens. We then create in this tutorial, we'll create 2 accounts. So fictitious accounts. We'll have the treasury account, which is us, client, and we have account 1 and account 2. We then create tokens. We then associate the 2 new accounts that we've created to those tokens, and then we apply what's called KYC, which is know your customer. We apply KYC to the accounts, and only then are we able to transfer tokens from the treasury to account 1, from account 1 to account 2. So that's what we're going to do. So you associate tokens to the account, so it associates the provided Hedera account with the provided Hedera tokens. So that's what we'll be doing. And then we've got enable KYC. So this grants KYC to the Hedera account. So again, go through this in a deeper dive. I don't want this video to be 30 minutes long. I want it to be a nice bite-sized chunk so we can actually get into the code so you can start understanding actually what we're doing and why we're doing it. So that's what we'll be working on. That is it actually. Oh, and then we've got transfer. Where's the transfer? Transfer tokens, and then lastly we'll be transferring tokens. So transfer tokens between 2 or many accounts. The transaction must be signed by the sending account, which we'll be doing in the code. Each negative amount is withdrawn from the corresponding account, which is the sender, and each positive one is added to the corresponding account, the receiver. So you've got a sending account and we've got a receiving account, which we'll be working on. So that's what we're going for. We won't be keep flicking back between the Python code and the docs. We'll just be plowing through, and hopefully you'll be able to download or clone a repository from GitHub and really do a deep dive of the code in your own time. So if I open up Sublime Text in my project, there we go. We've got Hedera Demo 5. Actually, I think this will be on the repository is 6. I'm just out of sync because one of them was just a setup video, but even so, it'd be did Python Hedera Hashgraph 6. So we've got create account, we've got get client, we've got messages, and we've got transfer. What we're going to need in this project is a new file called save as, and we'll call this tokens.py. And as always, I will open up my project on another screen so I can just move some code across. Right. Let's get my imports ready. Paste. Okay, so make that a bit easier for you to see. Okay, so what we've got here, so from get client, this is the same as the other tutorials. So from get client, which is this file here, we're importing the client, we're importing config user. And our operator ID and operator key. So that's kind of your public and private key with Hedera testnet. And then we've got from create account, import Hedera account and Hedera data. They're the 2 classes that we built in a previous tutorial. That allows us to create and configure new accounts, which we'll be using in this video. And then from Hedera, which is the library that we've installed, we're bringing in HBAR. No, we do need HBAR for this actually. Private key, account ID, and then we've got account create transaction. We've got transfer transaction. We've got token create transaction, token associate transaction, token grant KYC transaction, and token info query. So they're the constructors that we'll be using in this tutorial. We then got from JNIUS import auto class. So in the wrapper, it does most of the constructors and converts it to Python classes, but actually there's one called collections that we need in this video that we haven't got in the wrapper itself, so we need to do that. And then we've got import time, because we'll be adding or delaying what some of the calls so we can actually get the response and print out a response on the screen. Okay, let's save that. I will then, let me get the steps back up. So if you remember when I said at the start of the video, these are going to be the steps. So first and foremost, we want to create the tokens, okay? So we need a function to create tokens. Then we need a way to associate accounts. So we'll be creating accounts. So we'll be calling the Hedera account class, creating some accounts using a manager of some sort. So once those are created, we will then associate those new accounts with the tokens. We'll then enable KYC, or know your customer, and then we'll be transferring the tokens from the treasurer, which is us, to account one, then to another account. So they're kind of the steps we're going to follow here, okay? What I'll do, I'm just going to move across code and talk you through what I'm doing, because this isn't necessarily identical to what's on Hedera. I've fleshed it out a little bit more. So the first function is called create token. So we've got keyword arguments, and we're bringing through keywords decimals. So actually init supply. So the initial supply, remember I spoke about that a moment ago. You need to, when you're creating a token, you need to set the initial supply of the tokens. We'll be setting an initial supply of 1 million, and we'll be setting the decimals to 4. Okay. We then need to name the token, and we need to give the token a symbol. Also, we need to get the node ID, save. We need to get the node ID from the first account that we are creating, because we pass that through to the singleton list, which is one of the methods in collections. So we need to pass the node through. So we'll be doing that as well. So we need to slightly change the create account. Yeah, we do. Actually, we'll do that now. So we'll go self.resp, change this to self.resp, and then in the return, when we call create new account, we then want to bring through node, and that will be self.resp. I think it's node ID. Just double check. Okay, client create new account. Yeah, it's node ID. That's it. I was right. So yeah, we'll be getting node from the new account. So it'll be the node ID from the first account we create. So they're the keywords, and then we call a token create transaction, which on the documentation here, we go to create token. That is the constructor we're using. So token create transaction. That's why we're calling that there. And then we're calling a whole bunch of methods. Now, if you look on the docs, I don't think they've got hardly any on there. But actually, if you look on the examples on the GitHub repository that I showed you a moment ago, it has quite a few of these. So we're setting a node account ID. So this is from collections, which we're creating here using auto class from JNIUS. Setting a node, the token name, the symbol, the decimals, the init supply. That's what I'm passing through as keyword arguments. Operator ID, that's us. Then we've got set admin key. So that's the operator key for us. So we're setting all of these methods. So calling all of these methods by set admin key, set freeze key. And we're always putting in our operator key. So essentially we are the treasurer. That's what we're doing there. Set freeze default to false, and then we execute with client. So we are the client. And then we return the token transaction, get receipt, and we get the token ID. So when we call create token, what we get in response is the tokens that are created, and then we get the ID of that token that's passed through. Okay? That's the first thing we do. Then what we do is we create a class called tokens. We have a whole bunch of methods in here. So, there we go, tokens. We haven't done the init function here, and we pass through token and node. So when we instantiate this class, we'll instantiate it with the token ID that we've just created here. and we'll also add the node. So the node that we create when we create the first account, we'll be passing that through so we have access to it in all of our methods. So we have associate, we have KYC, and we have transfer. They're the three methods for this token class. We'll also have a token manager. So we'll have a manager that allows us to create the accounts and then actually call each of these methods individually in order, so we can actually work out what we're doing and when. In a production environment, you wouldn't build it like this. You'd build it slightly different. So you have human interactions. So you'll have a trigger from me as a user to create a token or to transfer a token. But this is just for a tutorial. So let's go on to associate. So we go back onto the docs and go on to associate tokens to an account. You've got token associate transaction, and then you've got these methods here. So they need the account ID and they need the token ID. Okay, and this is the Java here. So you can see what they're doing. They're calling token associate transaction. They're setting the account ID, and then they're setting the token ID. So collections.singleton list token ID. We're not doing it that way. What we're doing is we're passing through the node itself. So token associate transaction, we've already got access to token and node, but we're passing through, when we call it, we'll be passing through the account ID for the new account and the key for that account as well. Actually, not for the new account, that could be for the operator, the new account 1 or the new account 2, but we pass through each of them individually, okay, and we call this each time. So we've got token associate transaction, and we're calling these methods here. So we set the node, we set the account ID, so we get the ID from string, and we pass through the account. The token ID, so again, is collections, singleton list, self token. That's the token we pass through here. Then we've got a freeze with client, sign with the operator key, which is, because we're the treasurer, we're signing it. And then we sign again with the individual, the private key for the individual account that we're using to call it. So private key from string. So we always pass through the string of the key, not the actual object itself, and then we execute with a client. So that's what we're doing with associate. We're doing very similar with KYC. Again, I'm using the docs. If you go to enable KYC, they're calling token generate KYC transaction. That's what we're doing. And then it walks you through here what to do. So I'm just doing it in a Pythonic way. Go back into the code. So again, we're passing through the account, calling this class token grant KYC transaction, and then we're calling these methods. Okay, hope that makes sense. And then lastly, we've got transfer. So you need to transfer from the operator or the treasurer, which is us, first and foremost, which is a slightly different call to when you're transferring it from an account to another account. That's why I've got an if statement in here. So when we call transfer, we need to pass through the key, the account that we're transferring out from, the account that we're transferring into, and the amount of tokens. Okay? So if self key, so if we're passing through a key, that means that it's an account to another account. It's not the treasury. We're not looking at the treasury at all. So if we pass an account keyword through to this method, then we follow this. If we don't, then we follow this. So when we're transferring from the operator, so it should be the first transfer, all we're doing is we're setting the node account. Let me move that across a little bit. Make it a little bit smaller so you can actually see it all. Yeah, there we go. So when we're transferring it from the operator, we set the node account, we add a token transfer from and a transfer to, we execute with client to client, get receipt client. And so we're transferring out. So we set the token, the ID of the account we're transferring out from, okay? Remember, we pass the string, so we get it from string, and then we set the amount. So we always set, we'll be creating this and we'll be sending the amount as a negative. So minus 100. But the account we're transferring into, we just call absolute. So we make that minus 100 a positive integer and we transfer it into another account. So that will be transferring it from the operator or the treasurer to account 1. This one will be transferring it from account 1 to account 2. And you can see what we've got different here is we're using freeze with a client and then we're signing it as well. So we're signing it with the account that we're transferring it out from. We don't need to do that when it's from the treasurer. So they are the methods that I've got in the tokens class. Lastly, what we need is a manager. So a little bit going on here. I've already gone through the steps. Don't need that. There we go. So we've got a done the init method here. So as soon as we call manage tokens, it does a whole bunch of things. Okay, so pass through init supply, so the initial supply, the decimals, the name and the symbol. So as soon as we'll import tokens when we open up our command prompt, and then we'll call the manage tokens and we'll save it as a variable, and we'll pass through the supply, the decimals, the tokens and the symbols. As soon as we've done that, it then calls Hedera account, so it creates an account, and from that creation of the account, we get the account ID, the public key, the private key, and also we get the node, which is what we did when we put this here. Then we do it again, we create a second account, and we get customer account ID 2, public key 2, private key 2. So there are 2 new accounts that we're using. We then configure the accounts. I don't actually think that's needed. I think that was surplus. But anyway, we call config user client. So we can then have self client 1, self client 2. So if you remember in the transfer tutorial, when I was transferring HBAR from one account to another, you have to sign a transaction from the account. So you have to sign it with the new account rather than the operator. So that's why we use that. So that's a bit of a hangover. We won't need that, but they're in there anyway. We then got self token. So we're calling the create token function that we wrote earlier, passing through init supply, decimals, token name and token symbol, and also node. So if we look here, that's what we're passing through. And if the create token function will then return the token ID. So we then call, we can see that, we then call self, so we create a variable self.token transaction equals tokens. So we're calling the tokens class. So we're instantiating the tokens class and we're passing through node and tokens. So now on these methods that we will be calling when we open up our command prompt, we can now access token transaction and call associate, KYC or transfer. So when we call associate, can we see that? Probably not. Let's make it a little bit smaller. When we call associate, what we're doing is we're calling from tokens class, we're calling associate, and we're passing through the account ID, and also we're passing through the private key of the account. We're then adding a sleep, so for 5 seconds it sleeps, and then it prints out the associated count, and it'll have account ID is associated with token, and then it will print out token ID as well. So it'll be the string of the token, and then it does it for the second account. So what we're doing is we're associating the 2 new accounts to the token we've just minted, we've just created. So we'll call associate, then we'll call KYC, and it does a very similar sort of thing there. So it's calling the KYC method, passing through the account ID, and then it does a print. So it will print, we've granted KYC for account X on token Y, and it does it again for this second account. So at this point, we've associated accounts and we've enabled KYC on the 2 accounts. We're now in a position to transfer tokens from the treasurer to account 1 to account 2. Just looked at the time now. I think this video is going on now. So transfer. So must be a negative. So we need to, when we're calling transfer, we need to set a negative integer to as a keyword. So amount will be -100, and then we use absolute to send. So it's -100 from the sending account, be +100 to the receiving account. So we call transfer method. We add the operator key to string. So the operator ID. So that is not a string, that's an object at this point. So we create a string from that operator ID and we pass it through as the account out. This is who we're transferring it out from. The account in is customer 1, and the amount is what we just set there as a self.amount. Sleep for 5 seconds, and then it says we've sent X amount of tokens from account 1, or from account, this is the operator to account 1. So you can barely see that, but when it comes out on the CMD, you'll see what I'm trying to do. Once that's done that, we then transfer the same amount of tokens from customer account 1 to customer account 2. You can see here that I'm passing through key. Remember, because in the method up here, transfer, I've put if key. So if we actually pass a keyword, it will call that. If we don't, it will call this. Brilliant. And then lastly, I've got this other method at the bottom here, which is token info query. So that'll allow us just to get the information back from the token. We probably won't look at that. I was just playing around with that when I was doing the coding this morning. So that is all of the code. I'll just save the create account. If I open up a CMD, bring that down here and make it a little bit bigger. So what I'll do is work on Hedera. So you can see now, as always, I've got virtual env wrapper installed. So by using work on, I can actually use work on as a, let me spit it out. By having a virtual env wrapper, it allows me to access certain commands. And one of those commands is work on, which fires up any given virtual environment that I have. Okay, so in that virtual environment, I have the Hedera library. So work on Hedera, I've now fired up that virtual environment and we're good to go. So if we cd into the correct directory, which is development in my case, that's where I put all my projects, and cd into Hedera demo 5. Is it all underscore? It's probably all underscore. Nope. Let's have a look. Oh, it is not underscore at all. But I was right with the 5. There we go. So we're now in the correct directory. So if I now put Python, oh, that's correct. Yeah, I normally default to Python 3.9, but I needed 3.7 to work this. If you watched the last video, I had a few issues. So I need 3.7 for this to work. So let's go from tokens, import, is it manage tokens? Seems to work. What we'll do is we will call it token tran. Actually, have I got it in here? No, I haven't. So let's create a variable. So token tran equals, and it will be manage. This is where you find out that I can't type for shit. Manage tokens. So we need init supply. If you remember, these are the keywords that we need. So init supply equals, and we will have this as 1 million. We want decimals equals 4. Token, I think we call it just token name equals, and we'll call this DID, as in dumb it down. We have token symbol equals, we'll have capital D for decoding. Is that going to work? Well, it looks like it's doing something, which is great. Okay, so if you look back at the code, by calling that manager, tokens, so what I've just done, I've imported manage tokens, and I've called manage tokens class, and I've passed through init supply decimals, token name, and token symbol. So I've instantiated this class now. So I now have access to the methods here. So associate, KYC, and transfer. So what I now need to do is I now need to, by calling a class, if you remember, I've created 2 accounts. So I've got 2 fictitious accounts, account 1 and account 2. I now need to associate those to the tokens. And the way I do that is I call the method associate. So token tran associate. Yeah. And with any luck, what that'll do, that will now associate account 1 and print out a statement to say, there you go, associated account blah blah with token Y, and now associate the second one. There you go. So it's done that piece of work now. We now need to apply KYC, or know your customer. So if I just go back here and go KYC, fingers crossed that will work. Let me move the screen down. Granted KYC for account X on token Y. And there we go, granted KYC on account. This is the second account number to token Y as well. So we've now created the tokens, created the accounts, we've associated accounts to the tokens, we've enabled KYC on those accounts for those tokens also. So now all we need to do is transfer some tokens from the treasurer to account 1, and then from account 1 to account 2. We only need to call the transfer method, but we need to pass through a negative integer for the amount of tokens that we're going to transfer. So let's go and call transfer and amount equals minus, let's go 100 and enter. So that will reduce the treasurer account by 100, and it will increase the account 1 account number of tokens by 100. And there you go, that's just, there we go, happy days. That has actually worked, which is fantastic. I'm happy with that. So that is it for this tutorial. I hope that's a deep enough dive to get you started. Like I say, when there's a native SDK for Python, I would do a full top to bottom deep dive on the SDK, going through every single class and method and just really hitting it home. But whilst we're just using a wrapper, I'm just trying to get you started so you can actually start building these apps. This is a very top level scratching of surface for the HTS, it's the Hedera Token Service. I've just shown you how to create tokens, create accounts, associate accounts, apply KYC and transfer tokens from accounts, from the operator account or the treasurer account to account 1 and account 2. So we've done quite a bit actually, but there's so much more that you can do. You can delete tokens, you can mint more tokens, you can disable KYC. There's loads of different classes that you can tinker with. So have a good read of the SDK for Java and have a little tinker and see what you can build. I hope this video has been enjoyable and of interest to you. Please leave me a comment. It's always good to have some feedback. Also, subscribe and click that bell as well. Lastly, if you want to support this channel, help me make these videos quicker and of a higher quality, then by all means click on my Patreon page, which is in the description below, or send me some HBAR to my HBAR wallet, which is also in the description below. That is the end of this video. Thanks for watching, and I'll be seeing you in the next video. Thank you. Bye-bye.